collisions of celestial entities in space are beautifully chaotic. In the course of history, astronomers witnessed numerous spectacular colossal clashes between these enormous entities. But have you ever wondered what happens if two ultra-dense objects in the universe, such as neutron stars, collide? Will those two neutron stars collapse into a supermassive neutron star? Or will they combine and become a devastating black hole? In today's video, we'll show you what happens if two chaotic neutron stars clash. The true nature of a neutron star. When we think of terrifying things in the universe, the first thing that might come to mind are black holes. But if you look up to the sky, there is another astonishingly dense object out there, the massive neutron star. Neutron stars are the densest currently known type of stellar objects, aside from black holes. If you take 1 teaspoon of neutron star material, it would weigh around 1 billion tons. In fact, within a small pea, we can squeeze the weight of all 7 billion people on Earth. This is how extremely dense these neutron stars are. Not just that, neutron stars are also very hot, with surfaces reaching 1.8 million degrees Fahrenheit, 1 million degrees Celsius, compared to the Sun's measly 10,800 degrees Fahrenheit, 6,000 degrees Celsius. Neutron stars are really fascinating. What caused these neutron stars to become so incredibly dense? How are these supermassive stars formed? Well, they are created by stars just like our Sun. These stars are not destined to last forever. Stars emit enormous amounts of energy as they devour all of their fuels within their cores. Consider Betelgeuse, one of the brightest stars seen in our night sky. Betelgeuse, for example, is composed of a massive amount of hydrogen that serves as its fuel. There will come a moment where it has used all its fuel. In the case of Betelgeuse, it is nearing its end. The star will eventually crumble, with its core, the very center of the star, collapsing and crushing every proton and electron into a neutron. When the star reaches its end, the largest known explosion in space takes place, a supernova. The star's outer layers can blow off in an often spectacular display, leaving behind a small, dense core that continues to collapse. Gravity will continue to press the leftover material so tight that the protons and electrons combine and give birth to neutrons. Now, if the mass of the core of the collapsing star is 3 times the mass of the Sun, the newly created neutrons in its core can stop the implosion and will leave behind a tremendously dense neutron star. The first few seconds after the star begins its metamorphosis into a neutron star, the light emitted by the star's core is equivalent to the total quantity of light radiated by all of the stars in the observable universe. So, what will happen if two neutron stars collide? Hang on tight as we explain everything we know about this massive collision in a bit. To find the answer to this question, we must first understand some important discoveries of the world's most prominent astronomers. How many neutron stars have we found so far? The earliest indications of the existence of neutron stars were discovered in 1967 at Cambridge University, when a research student named Jocelyn Bell discovered a weird radio signal that was unlike anything she had seen before. The radio signal originated from the constellation Vulpecula. It was a series of quick, acute, strong, and exceedingly regular pulses of radio waves. The pulses occurred precisely every 1.33 seconds, much like a clock's ticking. Such precision led experts at the time to conclude that they had discovered signals from a highly sophisticated alien civilization. They even called the source Little Green Men, since they were very convinced it came from aliens. However, soon after 3 similar sources were discovered in widely separated directions in the sky, it became apparent that this type of radiation source was fairly common, and astronomers concluded that it was unlikely that these signals came from other civilizations. What they found back then were pulsars, which are a type of neutron star. Now, what exactly are pulsars? Pulsars are neutron stars that emit radiation at fairly regular intervals ranging from milliseconds to seconds. As of now, astronomers have discovered an estimated 2,500 pulsars. Next to pulsars, there's another less common type of neutron star that is much more powerful than your regular neutron star, the magnetar. If pulsars have powerful radiations, magnetars, on the other hand, have an extremely powerful magnetic field. The magnetic field of an exotic magnetar is expected to be 1 trillion times greater than the magnetic field of the Earth. If you were to come 600 miles or 1,000 kilometers in the neighborhood of a magnetar of 12 miles, 20 kilometers in diameter, you would die instantly. Its magnetic field is so powerful that it would destroy every part of your body, ripping electrons from your atoms and transforming you into a cloud of single atoms devoid of electrons. Only 31 verified magnetars have ever been discovered by our astronomers. Now that we know the true nature of neutron stars, what will happen if these massive objects in space collide with one another? What kind of mayhem will it unleash on our universe? When neutron stars collide. There are a lot of stellar constellations that are happening in space simultaneously, with scientists estimating that there are more than 100 million neutron stars in the Milky Way alone. There is a pretty good chance that some of them might collide. When two neutron stars orbit each other closely, gravitational force causes them to spiral towards each other. When these two freaks of nature ultimately clash with each other, experts believe that this chaotic event has two possible outcomes. Let's look at the first scenario. When black holes merge with each other, they create a supermassive black hole with super high gravitational power. In the case of neutron stars, it is not so different. When two neutron stars clash, they will merge into an ultramassive neutron star. In the span of milliseconds, extremely powerful gamma ray bursts will fly in every direction, causing disturbances felt through the entire universe. Even when neutron stars merge billions of light years away, the ripples of their fusion will reach us on our planet through faint gravitational waves. That is precisely what scientists witnessed for the first time in 2017 with the Laser Interferometer Gravitational-Wave Observatory, LIGO, in the United States, when they made the first detection of gravitational waves created by colliding neutron stars. When these neutron stars merged and spiraled together at incredible speeds, they emit gravitational waves that were detectable for about 100 seconds. When they finally collided, a flash of light in the form of gamma rays was emitted and seen on Earth for about 2 seconds after the gravitational waves were detected. Other types of light and electromagnetic radiation, including X-rays, ultraviolet, infrared, and radio waves, have been identified in the days and weeks following the massive impact. Now let's head to the second scenario. The two dense neutron stars will actually transform into a terrifying black hole. Scientists are not sure how to distinguish when a neutron star merger will result into a bigger neutron star or into a ferocious black hole. Scientists believe that if they merge into an entity with a mass greater than a certain critical limit, they will produce a black hole. But what is that limit exactly? This relies on how dense these neutron stars are. If the inside of a neutron star is very elastic or soft, it will collapse into a black hole. If the interior is stiffer or sturdier, it will not collapse, instead becoming a huge, rapidly spinning neutron star capable of defying gravitational collapse. Whether it becomes an ultramassive neutron star or a deadly black hole, one thing is certain: the ripple effect it leaves behind is powerful enough to be felt throughout the whole universe.